Hi, Year 10. This is lesson 4 on polynomials. This lesson we are going to talk about a new theorem called Factor Theorem. But actually, Factor Theorem is well related to our previous discussion on Remainder Theorem. Okay, so first let us to review what do we mean by factor in terms of number. Okay, for example, we know that 36 could be written as 4 times 9, and so we can say 4 is a factor of 36. Of course, you can also say that 9 is a factor of 36. So for the polynomial, for example, here we have a quadratic polynomial. If we could factorize this x squared minus 3x plus 2 into x minus 1 bracket times x minus 2, then just like when we write 36 as 4 times 9, this time we are going to say that x minus 1 and x minus 2 are two factors of the polynomial x squared minus 3x plus 2. Okay, so there's nothing special about that. So the special thing about using factor theorem to do that, to check whether something is a factor, is like this. First, let's see if you put 1 into px, so that's a value of a polynomial. Okay, then we're going to see what happens. If you put 1 into the polynomial, you will see that answer will be 0. Okay, and if you put 2 into the polynomial, and you will see that p2 is also 0. So what's the relationship between the fact that x minus 1 is a factor and the fact that p1 equals 0? Okay, so actually they are related. Okay, the same thing happens to when we have x minus 2 as a factor of the polynomial, and when you put p2 into the polynomial, you get 0 as well. Okay, so they are related. Okay, so if you still remember that last time when we learned remainder theorem, we know if you try to find a remainder without using long division, the method is you see what make the divisor 0. So when x minus 1, what make x minus 1 0? That will be 1. And you put 1 into the polynomial, you get the remainder. But this time, it seems the remainder will be 0, as long as they are factors. But this is true, right? Because we have learned if something is a factor, then when you divide that factor, the remainder will be 0. That's what we call factor. Okay? So here's the facts, or the factor theorem. So the factor theorem states that if x minus a is a factor of px, then pa equals 0. Okay? So why this is a? So remember when we learned remainder theorem, that a could make that divisor 0. Okay? So the trick is when we consider that x minus a equals 0, that's a x equals a, and you put that a into polynomial, it becomes 0. On the other hand, if you get a number which is a, you find that PA equals 0, then you will know x minus a is a factor. Okay, so it can go both ways. Just like when x minus 1 is a factor, then you will see P1 equals to 0. On the other hand, if we don't know whether x minus 1 is a factor, but you see P1 equals 0, then you can say x minus 1 is a factor. Okay. From the perspective of remainder theorem, we know if x minus a is a factor, then the remainder should be 0, because according to the remainder theorem, if you put a into x into the polynomial px, that means you are going to find the remainder. But since we've learned that from the factor theorem, if you put a, which could make that divisor 0, if you find that PA equals 0, then x minus a is a factor. Okay? Right, keep that in mind. Then we are going to do some questions here. For first example, you are going to find the remainder of a certain polynomial divided by each of the following linear polynomial. State whether the linear polynomial is a factor. So there are two parts of the question. The first part is to find the remainder. The second is to determine whether the linear polynomial is a factor. You need to state whether it is a factor. Okay. Right. How could we find the remainder? We must use remainder theorem. Okay. Before we use a remainder theorem, let's let Px equals the given polynomial. Okay, we'll treat this polynomial as a difference. Then you are going to see what would be the remainder when I put when this polynomial is divided by x minus 1. Still remember how to do it? First, you need to make that divisor 0. Okay, then you will find x must be 1 to make that divisor 0. Then you are going to substitute that 1 into the polynomial. Okay, so that's P1, and that P1 will be our remainder, because that's what remainder theorem is about. And that remainder equals, I'm just substituting 1 into x, and that number will be 0. Okay, so the remainder is 0. But we understand that if remainder is 0, then that's x minus 1 will be a factor. Okay, let's track b. For b, the divisor is x plus 1. Okay, you need to see what's the remainder when the px is divided by x plus 1. Okay, so you make that divisor equals 0, then you know x equals minus 1 if that's divisor to be 0. Okay, let's track. We put minus 1 into the polynomial. Okay, remember when this is minus 1, when you substitute into x, you better make a pair of brackets on it. Alright. Okay, to save time, I just give you the answer, and that one will be 4. Okay, so that means the remainder is 4. So remainder is not 0. If the remainder is not 0, then we know x plus 1 is not a factor of px. Okay. For c, it's x minus 2. Think about what number are we going to substitute into the polynomial. You need to see when x minus 2 is 0, x equals 2. And then you just substitute 2 into the polynomial, and this time you will see, and this time you'll find the result is minus 2. Okay, so the remainder is minus 2. It's not 0, so we know x minus 2 is not a factor. Okay. Right, from our first example, you could see when we substitute the number that make divisor 0, okay, into the polynomial, you will find the remainder. No matter what value it is, it will be the remainder. Okay. But then, if the remainder equals 0, so you know that factor would be, that linear factor would be a factor for the polynomial. Otherwise, that's linear binomial terms is not a factor. Okay, it depends on the remainder, the value of the remainder. Okay, so after the first example, can I give you some time to work similarly on this example 2 to see what happens? Okay, so again, you need to find the remainder of that polynomial. You need to find whether the linear polynomial is a factor. State whether it is a factor. Okay. Before we start, remember you need to let px equals. That will make your presentation easier. Okay. So, looking back for our previous example, can you do it by yourself? Okay, you might pause the video, try by yourself first. Okay, so look. So, in this question, all three linear polynomials are factors of the polynomial x squared plus x squared minus 4x minus 4, because each time you put the values into polynomial, it becomes 0. So there are 3 factors for this cubic polynomial. Okay, let's move on to example 3. In example 3, you are asked to show whether the first polynomial, which is a cubic polynomial, is exactly divisible by the second, which is a linear polynomial. Okay, so what do we mean by exactly divisible? When something is divisible by another thing, that means one is the factor of the other. Okay, so that essentially means you are going to check whether the second polynomial, which is a linear one, is a factor of the first polynomial. Okay, how could we check whether something is a factor? Of course, we are going to use Factor Theorem. Let's have a look at the first one. First, we are going to let the cubic polynomial as px Okay, then we turn to that divisor. So that divisor is x plus 1. We're going to find what values when we put into x will make that divisor 0. So you see that x should be minus 1. Okay, so to check whether x plus 1 is a factor of the polynomial px, you need to put that minus 1 into the polynomial p. By doing so, actually you are looking for the remainder. Okay, let's just do some substitution. Okay, from our substitution, you will see, of course, you better use calculator. If you are not quite sure about this, you are not quite happy with the way you're doing those power of negative number, you could use calculator. Okay, the answer for this is 6. So remainder is 6. So remainder is not 0. Okay, so you could say since remainder is not 0, therefore we say x plus 1 is not a factor of px. Okay, that's our first part A. Let's do part B. Okay, in the same way, we define px as our polynomial. The divisor this time is x plus 3, so let's make x plus 3 0 to see what value would be for x. All good. Then we put that minus 3 into polynomial p, and that's actually you are looking for that remainder. Okay, let's just do some calculation. Okay, be careful about the sign if you are not using calculator. Even you are using calculator, you need to be very careful. Okay. Oh, I think I make a mistake. Here should be 36. Sorry about this. Alright, so when you do the simple addition and take away, you got 0. Okay, so this time remainder is 0. So we say x plus 3 is a factor of our px. Okay, so that's basically A and B. Okay, let's try to look at the C as well. C is a little bit special. Okay, so for C, you see, this is a polynomial, but the special thing is that the linear factor this time is 2x plus 1. Okay, again, let's let px be our cubic polynomial, which is this one. Then I'm going to make our divisor 0. Okay, so to find the value of x, to make this divisor 0, you need to spend a little bit time on it. Okay, so actually you see the x you are going to substitute into the polynomial will be minus half. Okay, let's do it. Let's see If I put minus half into polynomial, what do I get? Alright, so you see, okay, so it's quite complicated. So square, that means becomes positive. Okay, so if you use your calculator to check, you will see actually the answer would be 0. Okay, so remainder is 0. So therefore, since remainder is 0, so we know that 2x plus 1 is a factor of px. That's it. Okay. For the last one, okay, I will give you the chance to do it by yourself, to have a go. Try to see if that cubic polynomial has a factor in 2x minus 3. Okay, so pause the video now and try to do it by yourself. Alright, so here's the answer. Okay, so the number you are going to substitute into x will be 3/2, because you need to make that 2x minus 3 equals 0. And after you substitute that 3/2 into the polynomial, you will have remainder as 15 divided by 2, which is, of course, not 0. As a result, your conclusion should be 2x minus 3 is not a factor of px. Okay, so let's move on to example 4. For example 4, you are given a factor, so you are given something is a factor of another polynomial, and you need to find some unknown coefficients. Still remember what do we mean by coefficients? Coefficient means a number in front of x. For example, in this polynomial, that's minus 2 is what we call coefficient of x squared. So you could observe for this polynomial in power 3, there's a k which is unknown as a coefficient of x. So how could you find k? They will give you a condition like x plus 1 is a factor. So that condition is very important. First, let's define this one as a polynomial px. Okay. Then we know x plus 1 is a factor, so let's first make x plus 1 equals 0, then x equals minus 1. So when we put minus 1 into polynomial px, it should be 0. Okay, let's write here, since x plus 1 is a factor of px, therefore p minus 1 would be 0. Okay, so p minus 1, that means you need to substitute that's minus 1 into x. Okay, and the result will be 0 because this is a factor. Okay, let's simplify, and you will see basically you will have one plus k equals 0. That means k equals -1. So that's it. Okay. Let's see part B. For part B, it's given x minus 2 is a factor of that polynomial. In this time, you see that two coefficients of that polynomial are unknown. One is the coefficient of x squared, the other is coefficient of x, but both are in terms of k. So anyway, we're going to use the same method as what we've done in part A. First, let px equals this one. Oh, okay, sorry, I missed one step. I should try to find the value of that x first. Alright, then I'm going to say, since x minus 2 is a factor of that px, therefore p2 be 0. So what do we mean by p2? p2 means you put 2 into x. We have done this many times now. Right, so you have 8 plus 4k plus another 4k minus 16 equals 0. So that will be 8k minus 8 equals 0. You put that 8 onto the right hand side, k equals 1. Okay, so that will be my second demonstration. How could we find the coefficients? Okay, so the last one, I'm going to give you a chance for you to try. Okay, let's pause the video now and try to do it, and then track the answer afterwards. Okay, so here's the answer, right? So you're going to check whether so you are going to use the fact that x plus 3 is a factor. So all you need to do is to put minus 3 into the polynomial, and this makes the polynomial 0, and you solve the equation. In the end, you will have minus 9/7 as the value of m. All good? Okay, so the last example, I should say, the last two examples will be the most difficult so far. It's about complex and familiar questions, and you are going to be given two factors rather than one. The reason that you need two factors rather than one is because the two unknown coefficients in the polynomial you are looking for. Okay, so how could we find m and n? So for this question, you need some previous knowledge from what we call simultaneous equation. This is for last term, if you remember. We will we are going to set up two equations, and we try to use the method of elimination to find the values of m and n. Alright, so first let's let px equals the given polynomial. Then we are going to deal with the first factor, which is x minus 1. I'm going to make x minus 1 0. So I'm going to have x equals 1. Okay, then I argue that since x minus 1 is a factor of px, therefore p1 equals 0. Okay, p1 is 1 to the power 3 square plus n times 1 minus 6 equals 0. So basically what you are going to have is, so I'm getting a little bit quicker here, so you are going to have m plus n equals to 5, and then you can't go further because there are two unknowns. We're going to set this one as 1, equation 1. Also we know for the second factor, okay, for the second factor we're going to make x minus 1 0, x equals to 2. Since we know x minus 2 is a factor of px, therefore p2 equals to 0. Okay, alright, we need to continue here. So this time you are going to substitute that 2 into the polynomial. Alright, so that's the substitution, and you will have 8 plus 4m plus 2n minus 6 equals 0. So that will give you 4m plus 2n. Okay, you will put all the number on the other side. Okay, so let's have a look on our first equation and our second equation. Okay, so when you compare them, you will see both the coefficient of m and n are not the same. So how could we eliminate them? If you still remember, we are going to multiply a number on 1 or 2, so that you will make the coefficient of one equation be equals to the other, will be equals to the negative of the other, I should say. Okay, so you might see that's a 4, but that's 1 in front of m for equation number 1. So if I multiply minus 4 to our equation 1, what I'm going to have, okay, remember when you multiply minus 4 to the whole equation, you need to multiply that minus 4 on both sides, not just on the left hand side. Alright, so you will have minus 4m minus 4m minus 4n minus 20. Okay, so that's our equation 3. For this equation 3, when you see that, you could see that's a 4, that's a minus 4. Okay, so when we add these two equations together, you could cancel that term m. So that's what we are going to do. We're going to add 2. Okay, going to add 2 with 3. So you will have minus 4m minus 4n equals minus 20. Okay, so then you will have 0 here minus 2n minus 22. Okay, so n equals minus 22 divided by minus 2, that will give us 11. Okay, if we got n equals 11, then we put that n equals 11 back to our equation 1. So back by 1 again, you will have m plus 11 equals 5. So m will be minus 6. Okay, so here's the answer. You have n equals 11. Okay, and m equals minus 6. That will be the answer. Okay. Okay, let me check if this. Yep, this should be alright. Okay. So let's move on to our last question. This one will be very similar to our example 5. So I better give you some time. You possibly need to rewatch what I've done for example 5 once at least, and try to do example 6. Okay, the things are very similar actually. They're essentially the same process, but it seems the procedure is quite complex. So I think you would need a lot of time to get it right. Okay, let's pause the video. You might spend 10 minutes. Okay, sorry, this is quite long. Okay, so px, you would need to use both the factors. First, you need to substitute minus 1 into polynomial px, and by doing so, you will have an equation a plus b equals minus 6 as your first equation. Then you use the fact that x plus 2 is a factor, and by doing so, you substitute minus 2 into the bracket, into the polynomials, and you will have 4a plus b equals minus 6. So when I remind you, you need to cancel out either a or b, but this time you see b is much closer because both are positive b. So if I multiply that minus 1 onto equation number 1, then you will have an equation number 3, which is minus a minus b equals 6. Right? So now you see that's minus b, and that's positive b in 2 and 3. Okay? So if we know this, we can add them up, and you will see that b will be cancelled out. You will only see that's that's 3a equals 0, because minus 6 plus 6 is 0. So you got a equals 0, and you put that a equals 0 back into one of the equation. Okay, you move back to equation 1, and you will have 0 plus b equals minus 6. So that b equals minus 6. That's it. Okay, so the answer is a equals 0, b equals minus 6. If you got it right, then congratulations, because this is really a complex and a familiar question. If you could get it right, possibly you will have a very high grade in maths. Okay, so do some practice, and do remember to send your finished work to my email. Although it's impossible for me to track in details for everyone's work, I do try to have a look to see how much you've finished. And also, if you have some questions to ask, you could still email me the question. You need to highlight the question, which question you don't understand. The best way to do it is to take a photo and send it to me. It will save me a lot of time searching for the question. Okay, so see you tomorrow. Goodbye.